Hi guys, so today we're going to talk about monsoons and the ITCZ. So we already talked about the different seasons of the Earth as it revolves around the sun. And when the northern hemisphere is tilted towards the sun, we have summer. When the northern hemisphere is tilted away from the sun, we have winter. When neither the northern or the southern hemisphere is tilted towards or away from the sun, but instead the sun's rays are hitting the equator mostly, we have spring or fall. So, one thing you should notice is whatever season is happening in the northern hemisphere, the opposite season is happening in the southern hemisphere. In other words, when it's warmer in the northern hemisphere, it's cooler in the southern hemisphere, and so on for the most part. And you'll notice that if we create a graph of the different months and the average monthly temperature in each hemisphere, we'll see that in the northern hemisphere, if we graph the monthly temperatures over the different months, in June, July, August, we're going to have the highest temperatures. And then in December and January, we'll have the lowest temperatures because in the summertime, June, July, we have summer. And then in December and January, we have winter. The opposite happens in the southern hemisphere. In the southern hemisphere, winter happens when northern hemisphere has summer. So winter happens in June and July in the southern hemisphere, and then in January and December, the southern hemisphere experiences summer. So for the southern hemisphere, when we create a monthly temperature chart, it should dip down in June and July because it's actually winter in those months for the southern hemisphere. So northern hemisphere monthly average temperature chart looks like this, and the southern hemisphere monthly average temperature chart looks like this. The letters here represent the different months, so January, February, March, April, and so on. So let's recap on the summer solstice. Remember, the summer solstice happens on June 21st, and this is when the sun's rays are most directly shining on the Tropic of Cancer, 23.5 degree north, because the northern hemisphere is tilted 23.5 degrees towards the sun. And then for the winter solstice, around December 21st, we have the sun's rays directly hitting the Tropic of Capricorn, which is 23.5 degrees south, because the northern hemisphere is 23.5 degrees tilted away from the sun this time, and the southern hemisphere is 23.5 degrees tilted towards the sun. Okay. And in the equinoxes, for instance, in March 21st and September 21st, the sun's rays are actually directly hitting the equator. And so that's why we have equal hours of daytime and equal hours of nighttime. Now, if you go back to your reference table, page 14, we've seen this chart before. Please read this area, this box right here carefully. It says, the drawing on the right shows the locations of the belts near the time of an equinox. The location shifts somewhat with the changing latitude of the sun's vertical ray. In the northern hemisphere, the belts shift northward in the summer and southward in the winter. What this is saying is, yes, we have planetary wind belts and we have areas or climates of low pressure and high pressure, wet and dry in different areas. We have different areas that have rising and sinking air as well. But this is not permanent. This is what it looks like during equinoxes, meaning March and September 21st, when the sun's rays are directly hitting the equator. And that makes sense because during the equinoxes, the sun's rays are most directly shining on the equator 0 degrees, and that means it's warmest at the equator, and that's where we have low pressure. The air rises in low pressure areas and then sinks in high pressure areas, and so on. But the thing is, in other seasons like summer and winter, this can shift. And what we normally focus on when we're looking at the shift is a zone called the Intertropical Convergence Zone, in other words, ITCZ, and it's a region near the equator where the trade winds of the northern and southern hemispheres come together. These northeast winds and southeast winds are called trade winds, and wherever they meet is a location we call the ITCZ. And this is the line, or this is the border, this is the zone that we look at when we're looking at the shift of all the planetary wind belts, either up and down when it comes to summer and winter. And for the most part, the ITCZ is the zone where the northeast and southeast winds meet and where it's warm enough for the warm air to converge and rise and cause precipitation and low pressure air. But watch what happens outside of spring and fall. So during spring and fall, or the equinoxes, most of my sun's rays are hitting the equator right here, and that's why my air is converging there, and then the air is rising and causing precipitation near the equator. But in the summertime, or just June 21st, my sun's rays are now mostly hitting the Tropic of Cancer 23.5 degree north instead of the equator during the spring and fall, right? So in the summertime, instead of the sun's rays hitting directly at the equator, it's hitting a little northward, closer to 23.5 degree north. And that's why this low pressure area, this ITCZ intertropical zone, also shifts northward. And not just this, all the other planetary wind belts shift with it. So this entire thing just shifts a bit northward. Okay, so that means my wet area, my low pressure area, and where the air rises also shifts a bit northwards. It's all happening a little far up north, kind of like this. My original line of ITCZ is closer to the equator, but now in the summer it's a little higher up north, taking the low pressure area with it. And notice that when it goes a little higher up north, it's there's more precipitation happening farther up north to where the ITCZ line is. The green and blue are areas of precipitation. And what about the winter? Well, in the winter time, remember, my sun's direct rays are hitting the Tropic of Capricorn, or 23.5 degrees south, meaning compared to fall and spring, where my ITCZ, or low pressure area, is closer to the equator, it's going to shift a little southward now because my sun's rays are hitting most directly a little southward, 23.5 degrees south. And now, as it shifts southwards, it's also taking the rain with it, right? Remember, it normally rains in the ITCZ area, this low pressure area, where because the air rises over there, right? Converges and rises. But now all of that is happening a little southward. So wherever the ITCZ line is where we're getting more precipitation and more rainforest and stuff like that, more greenery. Okay. So here's another picture. In July, my ITCZ line goes a little higher towards the north, and in January or during the winter solstice, my ITCZ line is going a little southward. And then in the spring and fall, my ITCZ is very close to the equator. Now, how does this relate to India and just South Asia and the monsoons? Well, remember, we said in summer time, India experiences monsoon rains, and in the winter time, India experiences dry areas. And we said it's because of the difference in specific heat between land versus water, but this is another big reason why India experiences seasonal monsoons. This is why. So in the summertime, we said the ITCZ line shifts a bit northward, right? It shifts up to India right here. And that's why in the summertime, since India is on the ITCZ line, or the ITCZ line is on India, it's bringing lots of rain and moisture there. Also, it's bringing low pressure area there, right? Remember, the ITCZ is a low pressure zone. And that's why winds go towards India during that time, because winds move from high to low pressure, and it brings water moisture from the Indian Ocean into India, and it causes rain. Now, in the wintertime, we said the ITCZ line shifts southward below the equator, 23.5 degrees south. And notice my ITCZ line is not on India anymore in the winter. It leaves a high pressure area here because the low pressure area moves much more southwards below the equator. And now India has a high pressure zone, and air moves outside of India. That's why during the wintertime, India is experiencing dry weather. Okay, so in the summertime, India experiences low pressure, and there's lots of monsoon rain there because of the ITCZ line shifts northward towards India. And notice that the high pressure is in the Indian Ocean, and winds move from high to low pressure, bringing rain, moisture, and rain. And then in the winter time, we have high pressure in India because the whole all the planetary wind belts are shifting downwards, right? So even though this wet low pressure area is moving downwards, this high pressure area on top of the low pressure area is also moving downwards. And that's why the winds are moving from high to low outside of India. Now let's talk about jet streams. We've spoken about jet streams in the past before, and jet streams are fast-moving air currents that form when cold air near the poles meet warm air near the equator, and this causes really fast winds going from west to east. And ITCZ, or the difference in seasons, also affect our jet streams, and how they circulate as well, and how they interact with the world. So remember, polar jets, we have two types of main jet streams, polar and subtropical. Polar jet streams form when cold air meet the warmer air from the mid latitudes, and subtropical jet streams form when warmer air in the mid latitudes meet the hot air almost near the equator. Then what happens is, when my ITCZ line is shifting north and south based on the seasons, my jet streams are also moving north and south. For instance, in the summertime, this polar jet stream right here is normally very close to Canada, almost moving from west to east. But in the wintertime, that jet stream, the polar jet stream right here, is shifting southward, more closer to the US. And it brings lots of wind, very heavy winds, into the United States from west to east. And it brings lots of storms too with it. And the storms move really fast as the jet stream moves. So this is why during the winter time, the US is experiencing lots of winds, normally because the jet stream is also moving south towards the United States during winter time. And in the summer, it's more towards Canada. Okay. And that's about it.